Hey guys, this is Coach Brian going over the 7.4 notes with you. Still talking about triangles, still talking about, right triangles specifically, triangles that have at least one 90-degree angle. And today we're going to be talking about a what's called a special triangle. There's, a couple types of special triangles, but this one specifically is the 45-45-90 triangle. So that's where you have your triangle. I know mine isn't perfect here. Let me clean it up a little bit. You have a triangle that has a 90-degree angle, and the other two are both 45 degrees. Okay, so that's what our 45-45-90 triangle looks like. This is also called an isosceles right triangle because an isosceles triangle has at least two sides that are the same. So if it has two sides, at least two, that are the same, and it has one right angle, it's an isosceles right triangle and a 45-45-90. So an isosceles right triangle has, two equal sides and two equal, and specifically 45-degree angles. And we can't forget that it has one 90-degree angle. Okay, so we can also call this triangle an isosceles right triangle. So we have this image over to the side right here, and we're going to just label some things on it and use it to help us keep our work organized. So the first thing we need to notice about this triangle is that it has a 90-degree angle. And from our previous days in this unit, when you have a 90-degree angle, a right triangle, the longest side is always across from that angle, and that longest side is what we call the hypotenuse. Excuse me. This also has two sides that match. Okay, has two sides that match, which makes it isosceles. Okay, so a couple things we can talk about here. We can talk about angles, and we can talk about sides. Okay, so first of all, we've got our angles. Our first angle, using our big capital letters, is A, and then we have B, and then we have C. And in this particular triangle, if you go back a little ways to earlier this year, we talked about the fact that if a triangle has two sides that are equal, like an isosceles triangle, that the angles across from those sides are also equal. And so what that means is that angle A equals angle C. And just doing some math here, quick little math, you know that all the angles in a triangle have to be 180. Okay? Angle B is 90. And so if we find out what's left, we're left with 90. And then here we just said A and C are equal. They're sharing that 90 degrees. And so they each equal 45 degrees. So we can say over here, angle A is 45 degrees and angle C is 45 degrees, and then angle B is 90. That's what makes it a right triangle. All right. On our sides, we can just kind of look at the lengths of the sides. We already know that the hypotenuse is the longest side, and it's across from angle B. So across from angle B, let me actually make that in a different color. Not let me undo anything. Across from angle B, we have the longest side, which is AC. That is our longest side. It's our hypotenuse. Across from angle C, we have AB. And across from angle A, we have BC. And these two are equal. How do we know they're equal? They have matching marking on them. So that signifies to us that they are congruent. All right. Moving ahead. Example number 1 gives us kind of this, this picture of a 45, 45, 90 triangle. And it's just a good reference for us for when we're solving them. This initial one has an x for both sides, and it has x square root of 2 as the hypotenuse. So that is right here. That information is right here. And just to prove this real quick, we could use the Pythagorean theorem. A squared plus b squared equals c squared. And if both the sides are x, okay, if a is x and b is x, that means that c squared is these two things combined. So if you have x squared and you add another x squared, you have 2x squared. And so c squared is 2x squared. And, sorry, forgot my square. If we are reducing that, we'd need to find the root of both sides, okay? And then this is just like we've been doing with our simplification. We can't do anything with this 2, but we can split this x into factors of x and x, and we can cross one out and kick one out. And so c equals x square root of 2, and that's where our hypotenuse comes in. Now you can do this with a few other numbers. I'll do, some of these that give you a starting number here, and they're like, hey, one side is 8, figure the rest of it out. Or hey, the hypotenuse is 10 square root of 2, figure the rest of it out. On this one, if one side is 7, okay, if one side is 7, we draw our little triangle real quick. If one side is 7, and this is an isosceles, that means the other side is 7. It's not letting me draw right there. And if we want to know the hypotenuse, we would say, okay, c equals the square root of 7 squared plus 7 squared. And so the square root of 98. And if you simplify that, you would get that it's the 7 square root of 2. 7 square root of 2. And I think you'll notice a pattern as you fill the rest of these out. One that I want to do with you, I want to do 2 actually. One specifically that I want to do with you though is if one of the sides was 1, okay, and the other side was 1. So I'm going to draw this one right over here. If I have a right isosceles triangle and the two sides are 1, okay, a squared plus b squared equals c squared. So 1 squared plus 1 squared equals c squared. 1 times 1 is 1 plus 1 times 1. So what's 1 plus 1? It's 2. C squared equals 2. And so you'd have to find the square root of both of those things. And we'd get that c equals the square root of 2. Sorry, I'm just kind of writing all over the place here. C equals the square root of 2. All right, one other one that I want to do with you. This one's a little bit more confusing, okay? I want to say, what if my hypotenuse was x? Like, what if I had a triangle where the hypotenuse was x? And I know that it's isosceles. So I know my two sides are equal, and I know my hypotenuse, but what are the two sides? Well, a squared plus b squared equals c squared. And so in this case, a and b are the same thing. These two are the same thing because it's isosceles. So if I because they're the same, let's say I make them both an x, Actually, let's not use x because I'm using that as my hypotenuse. Let's say they're both side. We'll just use an s. Okay, they're the same. So I'm going to say s squared plus side squared equals x. Okay, and x squared. Sorry. So now I'm going to put these two together. 2 times side squared equals x squared. Still trying to figure out what my side is. Okay, still trying to figure out what my side is. And then if I were to divide by 2 and find the square root, I would have that the side of the triangle equals square root of x squared over 2. Now, this breaks some of our rules for radicals, okay? The first rule that it breaks is that we cannot leave our radicand, switch back to my pen. We cannot leave our radicand, this part, as a fraction. So the first thing we would do is rewrite it like this. That's our first step. And then we would say, do these things have perfect squares? The square root of x squared is x. Okay, the square root of x squared is x. The square root of 2 stays down here. And you're like, okay, I got a little more simplified, but we can't leave a radical in the denominator. So we have to rationalize it. X times the square root of 2 is x square root of 2. Square root of 2 times square root of 2 is 2. That would be our final answer. That is what both of our sides would equal. And I know that seems a little confusing, but we're just following our basic algebra principles and using our simplifying radical principles that we learned earlier in this unit.